Hi everyone. Today's our session is on neural networks and deep learning in Python. This is Krishna here, and I have 16 years of IT experience, and I'm working as a system manager in an e-commerce company. So let's start with our topic, which is neural networks and deep learning. Okay, so this is going to be our agenda. We will talk about what is AI, then ML and DL. ML means machine learning, AI means artificial intelligence, and DL means deep learning. We'll also understand about what is machine learning and deep learning and the applications of deep learning. Then we will talk about neural networks and the structure of perceptron. And then we'll have a small example, which will help us to understand how deep learning really works. Let's start. So AI, ML, DL. So what is AI for you? What is artificial intelligence? Okay, let me put it this way. What is human intelligence? Let me tell you. So if you look at how we gain knowledge for a year of time. So we learn knowledge based on the experiences we come through. You learn from by doing some mistakes, or you learn from your parents or some other thing. Our learning happens over years, isn't it? And it will take some time to get into a mature stage where you know what is good, what is bad, and all that, right? Like it takes some time. Now think about the same thing you want to mimic with a robot or a device or a program that has to do just like how humans are doing. Like for example, a simple activity could be as simple as, let's say I come to a device and I ask it, what are the things happened today? And if it is able to tell me, then I could say it's an AI program, right? And now in this case, as a human, given that we have intelligence, we know about a lot of things, we are equipped with all those skills. For us, it is easy. But think about a machine doing instead of a human doing. That is called artificial intelligence, because the term artificial here indicates you are imbibing the knowledge into the device or a program. And when we say artificial intelligence, never assume it's always a robot will be an artificial. No, even your program could be a artificial intelligence one. So it is just in a way in robot, the program which is actually mimicking intelligence just like a human, that's called artificial intelligence. So artificial intelligence is just a name that is indicating that the intelligence is not something like a human thing. It's not a natural intelligence. It's an intelligence which is artificially put up. That's why the name artificial intelligence. And mainly the artificial intelligence is nothing but you can consider like another branch of science, just like how you have chemistry and physics and other subjects. Artificial intelligence is one of the subject which talks about how do we make computers think like humans. That's the main intent of it. And out of all this, you have got into multiple different paradigms or technologies like machine learning, deep learning, and all that. So they are like one or other trying to do the same. Now coming to machine learning, like artificial intelligence, if you consider this as a big umbrella, in that you have machine learning and deep learning. So machine learning, if you look at it at a very, very high level, it all talks about what are the different kind of predefined programs, or I would say a predefined models that could help us to do this learning. Like for example, how you learn to eat, like your parents might have taught it, right? Like this is how you have to eat, this is how you have to wash your hands. These are all being taught. Now the same thing, when you want to teach to a program, how do you do it? There is a way to, right? Like you have to somehow train it by using some data and all. So this training, or we call it as a learning. So these learning, different types of learning are possible. Like it could be right from a supervised learning, unsupervised learning, reinforcement, semi-supervised learning. There are a lot of type of learning which is possible. These type of learning models or learning programs are the key things in machine learning. So machine learning is all about different kinds of learning programs, which are generally statistical models. Those are being part of machine learning. And deep learning is one subset of machine learning where it is like a even beyond that. Some of the problems in machine learning where feature extraction was a big problem in machine learning, because to some extent only it could identify the features better. But with machine learning, one biggest problem is, like, let's say if you ask it to recognize a particular digit, which is an image, it might not be able to do as best as a deep learning model is. So deep learning is just one subset of models which will help you to do the feature extraction even more better and accurate. That's where the deep learning falls in. So your deep learning is nowhere different. It's just part of your machine learning. And why the name deep learning and all, we will see in further slides. So that's a high level about it. So you have one science, artificial intelligence, which talks about how you can make computers think like humans. And in that you have machine learning, and deep learning is just a subset of it. And machine learning is all about a bunch of programs that help you to make your programs learn and start doing something like what humans are capable of doing. So the same thing, whatever we are talking, that will be there. So artificial intelligence, which enables missions, we already discussed. Just also we discussed, like I said, machine learning is all about some bunch of statistical models which will help your machine. So here machines, so one big problem here is in textbooks or whatever, when people write machines, don't consider the machine means some hardware. No, it could be a hardware, it could be a program, it could be any device which you can make learn. It could be anything. So machine, when they mean, it's not just a robot. This is one thing I would like to clarify, because a lot of people, when they see machine, they think it's just a robot, because that's what's shown in movies also. It doesn't matter. It could be any program. Your Alexa is a simple example of a machine learning program, or a Siri, subset of ML. Now, I think we already talked about it. Okay. So what is AI? So actually, if you look at the history of artificial intelligence, right? The first actually artificial intelligence, there are a lot of research have been done, but the first artificial intelligence program, which actually proved that something like this can happen, like making a programs behave like humans is possible, is done by, doing something on a chess, actually. So they actually devised a program which could play chess with other players, and proved, and over a period of time, that program, which is actually playing chess with other guys, it actually proved that it will become better and better after some time, because it keeps learning. That's how they proved that something like that is possible. Because in general, if you see your normal program, right? Any program when you write in a normal programming languages, I mean, normally in programming languages, when you write, it is all about it takes certain input, process it, gets your output. That's all it does. Even though, let's say, the environment at which the program is operating changes, it doesn't change its behavior. It still keeps working the same way. But machine learning is not like that. So machine learning works completely based on how the data is being taught. And if at all there is some change in data, or if at all it learns something from environment, maybe it could change its behavior. That's where it actually differs from the normal programs. And that's where if you see in generally in machine learning programs, there is some feedback channel comes in. The feedback is nothing about which tells it, okay, this is what happened newly, or this is what the changes are coming in, so behave accordingly, something like that. So what and all you can do with machine learning? Like I said, you can even, I mean, the chess is the first one where they proved. And right now you see Siri, Alexa, all actually falls under machine learning programs. Where if you see Alexa, you might have heard about Alexa device, which is a product that Amazon has given. And that guy is capable of playing music, answering your questions. It is capable of telling your weather information. It is capable of telling, any English word you give. It is capable of telling the meaning of it, synonym, whatnot. It does a lot. Now, if you think underneath how that Alexa works is, given that I have some amount of knowledge on how it works, the way it works is whenever you say, hey, Alexa, what is the weather today? So when you say that what is the weather today, what it does is it takes your voice, and there is a synthesizer built inside the machine, which will actually translate into a text. That synthesizer job is to translate a voice into text. And there are a lot of synthesizers available in the market, by the way. And once it transfers the text at the server side, that means at Amazon server side, there is a program. I don't want to call out the names. Understand there is a program, a server program, which listens for that text. And as soon as it says what is weather, it actually tries to run its machine learning program, which actually tries to match what is the best match for this particular pattern. And based on that pattern, it already has data predefined for it saying when it is what is the weather, how you should react. So that code is already defined, or that kind of behavior to exhibit is already defined. And that's how it gets triggered. So once it happens there, what would happen is the behavior of it comes as a text, and that text transferred to your device. And from your device, from text to voice, it gets translated, and it voice backs to you saying, hey, this is the weather. This is what happens. And this is all in real time happens at a so faster rate. So generally, this is what happens. So if you see at the back end, your machine learning programs are running where it will take your question and answer back. But if you see in between, there are other technologies also involved, but machine learning plays a crucial role in giving you the right answer. So what is machine learning? Like I said, machine learning is nothing but a collection of statistical models, or if you want to put it simply, you can say a bunch of programs where that would help your program to make it capable of learning things. That's all. At a high level, that's how you can take it. You can call machine learning models, you can call machine learning algorithms, moreover, it is same. They are all statistical programs. So a few examples of statistical programs is, a very simple example is, let's say there is a program that would help you to say whether a particular email coming to you is a spam email or a non-spam email. That means you might be getting a lot of email, right? There will be a lot of junk email, something like this we have offer, that we have offer, and all that. So if it is able to recognize all those spam emails saying, oh, these are all junk emails, you can throw it out. And only the emails which actually interest you, it will filter out and able to give you. You can call it as a machine learning program. which does that job. And that will come under one of our machine learning model category called classification problem. Classification problem, the main concept of classification program is how you categorize things and bucket out things where you can identify whether it's on one category or other. Here in this case, spam, non-spam. In other case, it could be yes or no kind of situation. So anything like a Boolean use case or more than a categorical set of values. Something like that is what these classification problems are trying to solve. That's just one example of one type of learning. Apart from that, we have something called regression. We have a lot of other categories of machine learning models also available. So this is like a textbook kind of definition where, of somebody called Tom Mitchell from Carnegie Mellon University have actually formulated the definition of what is machine learning is. So he said a computer program is served to learn from experience E with respect to some task T and some performance measure P. If its performance on T is measured by P improves with experience, then you can call that program as machine learning. So what does he mean by a computer program is said to learn from experience E is, given that when you're training your program for a particular task, like for example, if I say the task T, in this case where they are talking about is identifying whether an email is spam or not spam. That is your task. And it learns over experience. That means it has read lots and lots of email, which is spam and non-spam. It starts learning. Only then it can able to predict. It starts learning. That is what experience they mean. And once it starts learning, how do you prove that that's a good machine learning program it is able to do correctly is using some performance measure P, where for that task, you will see whether the performance is acceptable or non-acceptable. That's what it means by P. So P is the performance measure, which actually helps you to identify whether your machine learning program is doing good or not. And generally 90% or above, you consider that program is doing very, very good. So that is what he is trying to say here. Now, why we have to learn about your deep learning? Like, for example, if you see, we have machine learning already, and we are saying machine learning has got a lot of learning models, which help you to teach how actually you can learn so that you can start doing predictions and all. Okay, perfect. Now, the question is why deep learning come into picture? So if you look at, like I said, there are few drawbacks in machine learning. So one of the drawback in machine learning is when your machine learning program has given a lot of dimensional data, like when I say you have one-dimensional data, two-dimensional data, three-dimensional data, when you increase the number of dimensions for it to work, it might not be performing as expected. That means you will see some kind of glitch in the performance happening, and sometimes it would even go worse. So that is one problem. So on high-dimensional data, it would be tough for the machine learning programs to operate. So that is one major challenge when it works, when actually the number of dimensions increases, the machine learning would not able to perform. So that's what you can see after it went high. That means the performance of machine learning very good for some time, but slowly it went to a stable state. That means it is not doing very well. But if you see deep learning goes up like that. The second major challenge is one other thing you might have, if you guys are working in machine learning or, you might have heard, one major challenge with machine learning programs is you need to tell what are the features it has to look for. It will not able to identify itself. So what does I mean by features is generally most of the machine learning programs work based on the data you give or the data set you give. Now this data set, what really happens is when you say data set, let's assume the data set is a two-dimensional data. That means rows and columns. That's called two-dimensional data. For a two-dimensional data like this, let's say you have a data set of 100 columns, which is like too huge. Do you really need those 100 columns? So columns, whatever we are talking about, are called as features. So what here it is trying to mention is when your number of features, that means when your number of columns are more, and if you're not telling it what columns to really look at, because that would be your key focus for understanding the entire data, your performance of machine learning might decline. It will definitely decline. The reason being you have to make your machine learning do too much, which is not necessary. So sometimes as part of feature extraction or feature removal, what you do is you actually combine certain features into one, which means combine certain columns into one, or sometimes you will remove certain columns, which might not be necessary. That is called feature selection. So these and all you do in order to make the programs work faster. Otherwise, your machine learning has to deal with a lot of performance implications. So that is one other problem which machine learning program has. Yeah. Clustering program learns from data. That's a different segment altogether, where clustering programs don't learn from data, but they actually learn from, clustering program also have data, by the way, just that clustering program do not have a labeled data. That means you will be given an input data, but that particular data set didn't talk about when this input happens, what is your output, but it do work on the data. And in that data also, maybe we need to apply certain features feature selection, because you might not need all the columns for training your algorithm. So this is called curse of dimensionality. This is exactly mean by, like I said, when the machine learning program start working on more dimensions, it might not be able to perform better. So this is an example of that curse of dimensionality, where it says more and more dimensions you are going to put on machine learning program, the performance of it slowly gets declined. Now, given that we understood deep learning performance well, even when your machine learning has to work with high dimensional data, so let's start understanding what deep learning can do. So deep learning can help you to recognize the speech and respond accordingly. It can also do the machine translation, something like you have asked it to read a number plate, and it is able to read the number plate and identify who is the owner of that particular car, or who is the owner of that particular vehicle based on reading that number plate. That is also one other example. Yeah, and it can also convert a particular banner which is in some different language and translate it to English. Like you might have seen Google Translator. That's the best example of deep learning. Okay. Similarly, the self-driving cars. Everybody knows about self-driving cars, and in self-driving cars, deep learning is one of the key technology which plays a role. There are other technologies also part of it, like computer vision and all, image processing. But deep learning is one technology. Once you actually capture an image using this computer vision and image processing, it actually learns from those images and does something. That's where your deep learning comes in. And similarly, predicting the future, that also deep learning can do. And chatbots, that is another example where deep learning plays a good role. Google AI eye doctor, if you haven't tried this, I would suggest you to try this particular app. It is very good. And there is this dream reading machine. These are all, don't take it like actual facts. They actually try to understand from your, from you, and try to predict things based on what it has learned so far. So deep learning, the another name for deep learning is neural networks. So neural networks, why they have named is from our neurons. Like in your brain, you have a lot of neuron cells, right? So from there, actually, they named that because why they named as neural networks is like overall, our knowledge is completely dependent on how our brain works and how our brain works using these neuron cells. And each of our neuron cells in brain is responsible for one particular skill. One neuron cell might be able to tell you how to see a particular object and how to recognize this is an object. Another neuron cell might be able to tell you something about your analytical capability. So each, like, there will be millions of neuron cells. So in that, here we are trying to explain how those neuron cells look like and what are the each and every entity of that neural cell does actually. Like for example, you have something called dendrite, which actually receives signals from other neurons. You have something called cell body, which is sum of all the inputs. And you have something called axon, which actually transmits signals to the other cells. So this is what the neuron looks like. And the same technology, when I say same technology, the concept will be applied. Even though we call neural networks being applied in machine learning, the neuron and all, it's just a myth, I would say. Exactly like brain and all. The conceptually, it might work the same way. That's what they were trying to show up. But it might not be as efficient as your neuron cells are. It's way far than that. But the technique overall, if you look at, moreover, it tries to resemble what a neuron in your brain does. And this is how a particular artificial neuron looks like. And this is how our neural network algorithms also look like. So if you look at an artificial neural network, there are basically three sets of components. One is input layer, which is this. Another is hidden layers, which is this part. And finally, there is an output layer, which comes it. So input layer is where it takes a different set of inputs, and there will be some kind of processing logic inside, which actually help you to process accordingly, which is what I was telling as hidden layers. And there are a lot of functions inside. Like here, it is talking about sigmoid function. Similarly, like we have activation function. There are lots and lots of activation functions, a centroid function. There are different kinds of functions available. And finally, you will get some outputs here. So that is the output layer. This is how a general artificial neuron looks like. And again, if you look at the machine learning, right, like I was telling about spam email, non-spam email, and the classification problem. Classification problem is one type of machine learning problem where it tries to identify whether a particular entity falls under one segment or other. So if you look at the spam or non-spam email, it falls into this category where it identifies certain set of things, whether it falls under, let's assume this is a spam email, these all green balls, and this is all blue dots, you can consider like a non-spam email. And your objective of machine learning problem is, when you're given a problem, identify actually a straight line, or identify a straight line which fits in such a way so that it exactly separates out these spam or non-spam. That is what you try to achieve in your linearization algorithms. And there could be certain cases where you cannot derive well the problem, which is what the non-linear problems are. For that, you have different set of use cases again. Now, this is just example of how an AND gate looks like. If you see, I mean, I hope all you remember about AND gate. AND gate is basically a logical circuit. When you say gate, it is nothing but a logical circuit with some set of inputs and some set of outputs. And generally, most of the gates will have one output as the signal, but it will have multiple inputs as the input values coming in. So if you see the way AND gate operates is, as you can see, this is what called as a truth table. Truth table is nothing but a combination of false and true values. Here, assume 0 is false and true is 1. So in this set of possible values, this is the chart or table on how an AND works. This Y is nothing but your output signal, which is this. And these two inputs, these two signal inputs are X1, X2. So it says from this, you can see AND gate will be 1. That means it is true only when all the values, input values, are true, which is 1. Any of the other case, it is 0. That's what this try to say. So let's assume this is what you want to do it. From this, if you see when you apply these inputs, which are X1, X2, inside this, like I was saying, the activation function or whatever, that could be something like this AND gate logic, where it does that processing and finally gives you whether it is 1 or 0, which is more of a classification problem, right? Classification problem is actually dividing, able to identify whether it is belonging to one set or other. And here also it will fall under that categorical set where it is either 0 or 1. So this logic, which we are talking about, how the AND operates, which we might be coming in the hidden layer, like in this place, like this one, not this one. That AND gate logic might be this sigma and bias including, and this sigma. And the final output, that 0 and 1 will come here. And your input signals, that whatever possible combinations of truth table values X1, X2 will come here. Your Y will be here. The logic of deriving that X1, X2 to Y will be here in this. So that is your function. This is just an example. So role of weights and bias, if you look at mostly the weights and bias, if you look at, they are basically a statistical set of functions. And each of that value indicates a certain, factor in deriving, how to derive a particular value. Like if you look at, let's assume this is the activation function, where it has something called f of x equal to wx plus b, where this is the weight vector. It's basically a pure mathematics and statistical model, where it talks about how you can get a weight value. And this S is the sum of inputs. And finally, when you see on a given set of weights, which is given, the way S is calculated is using this formula, where it says from whatever the set of values you have given, input values, that summing into the Xi, which is coming from the transfer function. So these weights are applied. Initially, it depends, like if you are using there are different types of neural network algorithms, right? From you have CNN, convolution neural networks, you have ANN, you have GNN. And each of these neural network algorithms operates in a different way. Initially, what happens on these machine learning algorithms, particularly on the neural networks, some of the machine learning algorithms initially assume a random weighted values. So these are inputs X1, X2, X0, assume they are in your inputs. And these W0, W1, W2, initially, some of the algorithms might assume those as random values. And over a period of time, when they go into these the hidden layers, those weights will be set accordingly so that the feature will be extracted in a better way. So that also will be done. So each algorithm is different in its own way, where once you work on it, you will understand how those being taken into account. Now we will look at a small demo example. It is more about understanding how you actually machine learning program will recognize a particular digit. This is the one. So like I was saying, if you remember, I was saying that any neural network algorithm will be having 3 layers: input layer, hidden layer, and output layer. And there could be a bunch of hidden layers. The more and more hidden layer, that means more and more complexity will keep going in, where it has to do a lot of job in terms of identifying the right weights and doing the mathematical function accordingly. Like if you see, one example is in the input layer part, if you see, they are being given a lot of images, and its job is to recognize that image belongs to which particular person. Let's say that's an example. Now, in the hidden layers is where the entire logic, where each hidden layer will be able to identify, like one hidden layer, one layer might identify the neck. Another hidden layer might identify the curves on the face. Another layer might be identifying the eyes. Another, so each of these, like these circles you are seeing, those are called as neurons. And each neuron might be actually responsible for some particular feature of your face. Like in this set of images which you are throwing to this algorithm, let's say it has to recognize a face. In this circles which you are seeing, which are called as neurons, each neuron might be responsible for one thing. One neuron might be trying to identify the structure of eye. Another neuron might be trying to identify how the eye looks like. So each of them will be responsible for different features. And finally, when it goes through multiple hidden layers like this, it gets more better. And finally, it gives you an output that how that face gets recognized and all that. So that's why here we are trying to show initially, this is what it understands. Then you can see from hidden layer, it actually able to get to something. And after this hidden layer, it was able to even give something like this. So that's how it actually gets and finally gives you a right answer. Now, this is what we are talking about: input layers, hidden layers, and output layers. So there will be lot of hidden layers, and all these neurons are connected to one another. And it is like each output of one layer. Like for example, this, once this takes input from all these input layers, one of the input layers, this hidden layer will keep sending its output to another layer. So each neuron will be feeding its getting the feeding from the previous layer, and it does something and again passes it. So over a period of time, that particular entity gets more better when by the time it comes to the output layer. And in this is where the activation and all weight and bias, all that thing happen in the hidden layer part. Like for example, this MNSAT data set is more about, let's say you have different ways of writing numbers. Like if you see, these are images. 0 you can write in different ways. 1 you can write in different ways. 2 like that. 3, 4. If you see different ways of writing the same digits. Now, how you can make a machine learning program or a deep learning program understand this? So in this case, if you see, your digits and different shapes will all go here. That 0 or 1 or whatever. So how many input neurons you need? So that is what comes here. And finally, your output will be whether it's a 0 or 1 or 2 or 3 or 9. That means it is like up to 10 layers, right? That is the output. But input could be any one of them. So input is nothing but this particular 9. This is like a 10 by 10 matrix kind of, if you look at, right? So you have 1, 2, 3, 4, 5, 6. You have 10 here. You have 10 here. So it is like a 10 by 10 matrix. So those are the set of inputs possible, which will come here. And from there, how it recognizes particular digits. So a simple example could be, let's say, if I want a program to understand a neural network program. So it might have learned about a lot of zeros to identify that as a number as 0. So one neuron cell might be identifying this line, which is slanted. Another neuron might be identifying this small 0 thing. Another neuron might be identifying this thing. Another neuron might be identifying the way 0 actually circled here. So like that, it tries to find each neuron will be responsible for one feature of that particular object. And finally, based on what it has learned, it finally able to derive that this is going to be a 0 number. Similarly for 1, similarly for 7, for all of this. Okay, thank you all. Thanks for your time. See you. Bye.